Hello, Calculus 2. Moving into Chapter 10. Chapter 10, just a little outline quick here. Chapter 10, 10.1 talks about conic sections. That's a little strange. Actually, the title is Conics and Calculus. But conic sections is kind of an old pre-calculus idea. But anyway, we're going to do some of that, remind ourselves of that. As we move on, we kind of switch gears. We do 10.2 and 10.3, talk about parametric equations, where we might run into some parabolas and ellipses and stuff like that. So maybe that's why we're studying conic sections a little bit. But parametric equations are really cool, man. I love that. And then we switch gears again. We go into polar coordinates, a whole new coordinate system. Instead of the good old X and Y rectangular coordinate system, we can learn about polar coordinates, the last part of this chapter. So it's kind of funny, disconnected ideas in a way, but there's some connections in there. I'm going to erase this. That's just a little outline of the chapter. And I want to start talking about these conic sections. So I've got all these equations written up here. I guess sometimes it's good to pause and you can kind of write this down or look at it. So here they are, the conic sections. You know, I could list them for you. There's a circle, ellipse, hyperbola, and parabolas. There's four of them, I guess. And it comes from slicing a cone with a plane. I won't get into that. There's some nice pictures in the book. The conic sections, circles, parabolas, ellipses, hyperbolas. So here's some equations. This is the equations in standard form. I didn't label them yet, you know, but they all come from what they call the general second degree equation. It's interesting. Ax squared plus bxy plus cy squared dx ey plus. So a general second degree equation can get put into standard form, and it'll get put into one of these forms, and it'll be either a circle, ellipse, parabola, hyperbola. Yeah. Now, how do you get from here to here? And maybe you remember some algebra. Basically, if you have this form, you have to complete the square. Maybe you have to complete the square a couple of times to get to these perfect completed squares like this and put it into this form. So we can practice some of that. First, I just want to talk a little bit. Now, one of the things, when it has this term in there, this is an interesting term. When it has that bxy, that is a rotated conic section. Dude, that's like instead of a left or right parabola or an up and down parabola, you could have a parabola that's rotated 45 degrees or 30 degrees or whatever. Instead of an ellipse that's horizontal or vertical ellipse, you could have an ellipse that's tilted, that's rotated. Doesn't apply to a circle, I don't think, if you try to rotate a circle. So we won't deal with that. They took that out of this section. We used to deal with it. I used to be quite a pain to deal with those guys. I might mention something about them. So for our case, this b will be 0. This term will be gone. All right. So maybe you can guess what this first one is here. X minus h squared, y minus k squared. By the way, that hk is the center. That hk is the center. And for this very first one, it has this r squared. R is the radius. So that's a circle. And so I'll write that down. That's a circle. And, over here, to refer to him, how do you know when this is a circle? And what you have to have is that x squared and that y squared, and they have to, the a and the c have to be the same. The a and the c have to be the same. So I'm going to write that little note here. A has to equal c, and you get a circle. You know, that HK is the center. I wrote down center. That's true for the circle. That's also true for this next one and this next one. They're just a little bit different. This one has the plus sign. This one has the minus sign. This is an ellipse in standard form, and this is a hyperbola in standard form. Now again, just go back to refer to this. How do we know whether we've got an ellipse or a hyperbola? Well, or a circle. And again, it's all about that a and c, that coefficient on the x squared and that coefficient on the y squared. It turns out, you know, if these two numbers, a squared and b squared, were the same, they'd be a squared and a squared. You multiply them, you'd have an a squared over here, which is basically, so when these numbers are the same, it's a circle. When these numbers are different, that's what makes it an ellipse. So when they're both positive, but they're different, so a does not equal c. When the a and c are different, that makes it an ellipse. But they are both the same sign. As soon as a, well, actually here, the a could equal c or the a could not equal c, what's crucial is that one of them's minus and one of them's plus. So a and c are different signs. One's positive, one's minus, one's negative. If they're different signs, then it's a hyperbola. So a equals c, they're the same sign. A does not equal c, they're the same sign. That's a circle, an ellipse. A and c are different signs, that's a hyperbola. And we'll talk about these more in detail. This is a general introduction here. But in all these, the h and k is the center. And the a and b are, you know, I got to talk to you about other things. But the h and k is the center. That r is definitely the radius. The radius is r for the circle. We know about circles already. Hey, these last two, if you notice, the x is squared, the y is squared. Let me put an or here. X is squared or the y is squared. You know, over here the x is squared, the y is not. And then in the other one, the y is squared, the x is not. So when one of those terms is squared, we know that's a parabola. These are parabolas. And here they are in standard form. We got to identify what that number p means. It's the distance from the vertex to the focus. When you are talking about a parabola, you don't call it the center. That hk is now called the vertex. It's the vertex of the parabola. And how do you get a parabola then? Well, you can't have an x squared and a y squared. One of these has got to be gone. So either a is 0 or c is 0. So you either have an x squared and not a y squared, or you have a y squared and not an x squared to become a parabola. So that's cool. That a and c dictates how do you get from that general second degree to one of these conic sections. All right, that's enough there. We need to work on some of these. I'm not really going to talk about circles. That's all you got to say about a circle. It's got a center and a radius. Ellipses, hyperbolas, I do tend to minimize a little bit. Parabolas and ellipses I talk about a lot, so we got a lot of cool stuff to say about them. All right, do some homework.